Good morning, everyone. So my name is Alan Pullivan. What I plan to talk about this morning is ostensibly testing, but it's not really testing. We'll talk about test-driven development and behavior-driven design or behavior-driven development or however you want to call it. What it's ultimately all about, though, is writing code, and what it's ultimately all about is designing. So we're going to be really looking at how to use the testing process as a design process. And I will demonstrate it, and well, first I'll do a bunch of slides, and then I'll demonstrate it. So that always seems to work that way, doesn't it? You have to wade through the slides before you can look at what's required. I'll be at the conference. I'll have questions afterwards, of course, but I'll be at the conference if you don't have a chance to ask questions. I'm also going to be around tomorrow if anybody's doing a postcon. So I'm going to do a session on design patterns tomorrow. And I have a bunch of business cards up here. Just help yourself if you want to get hold of me by email or something like that. There's also a mailing list that you can sign up for if you want to. So, why is this not? Okay. The other thing I'll say is that there's a video on my website that is about a 10-minute distillation of everything I'm going to spend the next hour and a half talking about. So the course notes are, of course, on the conference site and also on my website. But this video might actually be more useful because it's dynamic and it shows me actually coding, which is something you're not going to get off of the PDF slides. So just go to my website and the videos and you'll find it. Now, as I said, the notion of designing by coding is built on the notion of test-driven development. And in fact, BDD is really built on the notion of test-driven development as well. Dan North, who came up with it, his basic idea, basically what he said is, this is my take on doing test-driven development correctly. So really, these are all just different flavors of the same thing. Neither approach really is a testing methodology, though. In other words, it's a way of developing code so that once that code is developed, you have unit tests and some acceptance tests in place for all of the code that you're developing. But in a way, that's kind of a side effect, because there's a whole bunch of testing that you have to do that TDD will not do for you. It doesn't do any kind of stress testing. It's not really going to test the UI. It's not going to do any kind of Selenium sorts of testing. There's a bunch of tests, in other words, that you have to build in order to fully test the system. If, however, you're using TDD techniques, you will have a complete set of unit tests or close to it. And those unit tests will be completely automatable, which is a good thing. The other thing that's nice about it, and we'll see why in a minute, when you're using TDD techniques, you get almost 100% test coverage on the unit tests. So that's a good thing, obviously, and it's good to get it kind of for free. However, it does require you to think about testing in a different way than you're used to thinking about testing, because when you're doing TDD-style techniques, you're actually building the tests before the code exists, which is a whole different approach to testing than what we're used to. For one thing, when you build a test, you can't make any assumptions about how the implementation looks. And that's actually quite important, is that the implementation is going to change. If you're working in an agile environment, of course TDD is coming out of the agile world, the code changes constantly. So if you write tests with some knowledge about how the code works, then the test is likely to succeed when it shouldn't, or fail when it shouldn't. More to the point, when you change a test, you never want to be changing the code at the same time, or vice versa, right? Because if you change the code and change the test at the same time, you might have introduced bugs in both places simultaneously, in which case the test could succeed or fail incorrectly, right? So everyone see what I'm getting at is that it could go both ways. So you never want to be changing both at the same time. So why do you want to do it? Well, the whole test-driven development techniques remove a lot of stress from the process of programming, which is to say that since the test is in place before the code is in place, as you're working on the code, you can be running the test every couple of minutes. And if the test continues to pass, you know that what you just did in the last couple of minutes worked. And that's actually pretty valuable, is that, for me at least, it lets me code faster, because I can code intuitively without having to stare at what I just wrote to see if it works or not. In other words, if I can just intuitively write a bunch of code, hit the test button, it's green, and I move on. That's actually a faster way to work than having to stare at the code after you write it to make sure that it works before you move on. More to the point, if it doesn't work, well, I just spent 2 minutes writing the code that didn't work. If it's going to take more than 2 minutes to find the bug, I'll just throw the code out and rewrite it. So it gives you options that you wouldn't otherwise have, and those all make for a much less stressful environment. It reduces development time as a consequence, is that the code goes together very quickly, is that eliminating that stress, as I said, lets you code intuitively. And if you're not coding intuitively, you're really having to look at the code twice, once when you're writing it and once right before you test it. This way you can eliminate that second step, so it makes everything go faster. It allows you to refactor, and that's a very important issue, is that it's the core of all of the agile processes are these notions of constant, is this notion of constant refactoring, is that very aggressively, brutally refactoring is sometimes called. Every time you look at a piece of code, if you find something wrong, you fix it immediately. And the time required to do that is just bolted into the process. Is that, in other words, it's not, if you're really doing Agile, you can't not refactor. So if you are skipping over bugs or allowing any bugs to exist inside your code while you're writing it, you are not doing Agile. Now, test-driven development allows you to refactor, because if you don't have your unit tests in place, you can't refactor safely. In other words, if you're modifying the code to behave the same way that it does now, but work better, well, how do you know that it behaves the same way that it does now if you don't have a test in place? So refactoring is not possible unless tests are in place. And in fact, one of the big things that people have to do when they transition to Agile is put those tests in place. Is that it's rarely the case that an existing body of code that was built in a typical waterfall shop with a bunch of kind of ridiculous arbitrary time deadlines has enough unit testing. Because people always say to themselves, oh, I don't have time to test, and they never write the tests. In an Agile shop, you don't do that. Is that the code has to be as good as you can do it, right? The only acceptable defect rate is 0. So if you're going Agile from day one, all these tests are already there, but if you're moving into Agile, you've got this big pile of code, and typically there are no unit tests on it. The first thing you're going to have to do, though, probably is refactor the code, because if any of you have been sitting through some of the other architecture talks I've been giving, the code has to be written in such a way that it can stand up to the stress of being changed all the time. So the first thing you're going to have to do when you start moving towards Agile is modify the architecture a little bit so that it can stand up to the process. If you don't have the unit tests in place, you can't do that. So usually the first thing you have to do before you actually write any code, before you really become Agile, before you start using any of the Agile techniques, is to spend a month going through the code, adding all the tests that ought to be there but aren't. So in order to be able to refactor. So that's an important first step. 100% coverage I already talked about. It also improves the architecture. We'll see why in a moment. But the basic idea is that we're going to start from stories. And I talked about stories yesterday in one of the sessions that some of you were at least. And the thing is that an Agile architecture that's a good one is built around the domain. It focuses on the stories. The key classes in your system are classes that have names that exist in the domain. A customer ought to be able to look at the code at a high level at least and be able to actually make sense of it. Is that the class names will make sense to them, the things that you're asking a class to do will make sense to them. The architecture then has to reflect the domain very closely, and TDD techniques tend to force you in that direction. They tend to keep you focused on the domain as you start writing the code, so the architecture gets better as a consequence. A couple of other important issues. Often when people are writing code, they say they're blocked. I can't go any further because the database isn't finished yet. Well, and in the Agile world, that's not an excuse. Is that you can't say that. So the question is, how do you move forward in a situation where multiple teams are working on different parts of the system and something isn't finished? And the answer is that we're going to use a mocking framework to do that. I'll demonstrate that in a moment also. So the idea of mocking is that you can take an object and not implement it, or rather implement it very lightly. Implement it lightly enough so that it appears to work. Everything you try succeeds. It might not do anything real, but it appears to work. So if you take your database and wrap it in an object, the object that is using the database must appear to work. Even if you're doing something like fetching data out of the database, and you shouldn't be doing that, I don't have time to go into that, but all the object-oriented stuff I've been talking about all week is about that. you can still simulate that process. In other words, you can simulate a database call that came back with a result set just by building a result set by hand and pretending that that actually came from the database. So this notion of mocking is central to the idea of testing in a test-driven development way, because I said when we're going to write the test first, so most of the code isn't going to exist yet. So we can't, if we were blocked because some piece of code wasn't written, we wouldn't be able to go forward at all. So initially, almost your entire program is going to be built around simulations. It's going to be built around things that are pretending to be something else, or at least code that pretends to work when it doesn't actually work. So this notion of mocking, of a little stub that pretends to do something, is an important part of all of these techniques. Now you also have to be thinking about what you're testing. The thing you're testing here is the donut. The thing that people tend to forget about when they think about testing is that donuts have holes in the middle of them. In other words, you like to be able to test an object from the outside, and you want to be able to test the object as a black box. Now, that last statement is particularly important because, again, in the Agile world, we're changing the code all the time. So if you don't test it as a black box, in other words, you call a method and you check to make sure that the method behaved the way it was supposed to, then you don't have the luxury of changing the object. So you can't, for example, run a method and then look at the fields of the object to see if they're in the state they're supposed to be in. That's a technique that will not work for you in this environment, because those fields might change over time. And you want to be able to change the implementation of the object without having to modify the test. So you need to write your code in such a way that you can do that, which means that the classes and so forth have to be complete black boxes. You can't have any notion at all about how they work. Which of course means you have to design an API for the object in such a way that you can determine that the test worked. So you're designing for testability to some extent here that you wouldn't be if you were not treating the object as a black box. Now that said, the object is going to be using other objects too. In other words, you think about black box testing, you think about testing from the outside. Well, actually there are objects inside that are being used by the thing that you're testing. And sometimes you have to test that those objects are being used properly. So there's always a notion here then of the so-called servants, right? The things that are inside the object that the object is using, and those have to be tested also. So let's skip that one for a moment. The other issue that's important is that a mock is a simulation of a working object, but sometimes you actually have a working object. And you just want to make sure that the object was used correctly. Right? This happens inside the donut hole, but it also happens outside. So when we go into mocking parlance, people talk about two things. They talk about mocks and spies, and it's important to distinguish between them, as most of the mocking frameworks give you both approaches. So a mock is basically a minimal implementation of some interface. Doesn't actually do anything, does implement all the methods of the interface, it always appears to work. A spy is a wrapper around an existing thing. And often spies are very lightweight in the sense that they'll just monitor how many times something was called. Or they'll record what the arguments were and then what the return value was associated with that call so that you can look at that recording later. But all of the work is being done by the actual object that's inside. Sometimes you might intercept the method call to the interior object and do something and not actually call the real function. I do this a lot when I simulate, when I write. Java, I work in Java a lot. Java has a system class that represents the operating system. And in that system class is a means of reading the environment variables. Well, when I'm testing, I don't want to have to go out and actually modify the environment variables in my test environment in order to run the test. So it will often be the case that I will spy on the system object. In other words, the system object is part of the system. I can't touch it, I can't modify it. But I can put a wrapper around it that appears to be the system object. So that when I ask the wrapper for the value associated with a particular environment variable key, my function runs rather than the real one, and then my function returns what I would expect to be there if the environment was set up correctly. Everyone seeing how this is working? Now, in strict test-driven development, those guys look down at spies. They don't think that they're appropriate because they're not thinking in terms of using test-driven development on fully built systems. They're thinking about using test-driven development as a way to build the system, but they're not thinking much beyond, once it's built, now what do we do? When you're using TDD kinds of techniques for doing architecture, well, your architecture is incrementally developed over the course of the life of the program, which means that for the vast majority of the time, the vast majority of the classes that you're going to be using already exist. I don't want to simulate those using mocks. It's much better to just wrap a spy around the existing thing and use spies. So I use spies rather heavily when I'm coding, even though the TDD guys don't like that. It's just too bad. In terms of the stuff inside the donut, we want to be starting to think about dependency injection. So, in other words, if you are testing an object, and the only way to validate that that object is behaving the way you expect is that the object has interacted with something that it contains in the correct way, then you have to inject that contained thing into the object from the outside in order to do that testing. Now, injection can happen in two ways. Typically, it happens with a constructor argument. In other words, rather than just creating something in the constructor, you pass the thing into the constructor as an argument. That way you can pass a spy or a mock into the object that you're testing rather than the real thing. Sometimes you don't want to do that because it clutters up the constructor with arguments that are meaningless to people as they don't understand what they're about. So sometimes it makes sense to just put a method in your class that does nothing but inject some stuff into the class that you're testing so that you can't test it. So when I talk about, for example, designing for testability, that's one of the things I'm talking about. Is you might have a method that exists only for the test framework to use. And that method takes as its arguments the interior things that you have to monitor. And it replaces whatever the default things that you have to monitor would be inside the object itself. And you don't use the constructor in that situation because why clutter up a constructor call with 5 or 6 arguments that are only used when you're testing? Is that it makes the code harder to read if you do that. So it's better to have a separate method that's doing it. Is it making sense to everyone? Okay. Now, looking at the TDD process, it's pretty straightforward. And my cursor is what's giving us that strange hairline. So looking at the TDD process, it's pretty straightforward. First order of business is you write the test. And it should be a small test, a couple lines long. Generally speaking, the feeling in the TDD community, and it's hard for me to argue with it, is that a test should only have one assert in it. Right? And that's what a test is, right? Have all of us used any of the XUnit or equivalent testing frameworks? Has anyone not done that? Okay, good. So basically your tests are a series of test methods that have assert statements in them. And you're asserting that something is what you expect it to be. Well, how many asserts should you put into the test is one of the questions. And the answer is as few as possible, because if there are too many asserts in there and the test fails, you're not quite sure exactly why it failed or where it failed most of the time. It's much easier if the tests are very, very fine in terms of their granularity. So the tests start out very small. The second thing you do is you run the tests and the new one should fail. Right? It almost always fails when you run it, because the code that you are going to test doesn't exist yet. So of course it's going to fail. And if you're mocking it up in the simplest possible way, well, the odds are about 50-50 that it will fail, right? In other words, if the method returns true and you expect it to return false, it'll fail. And then the other applies too, right? The other half of the time it'll appear to work, but most of the time it'll fail. So the next thing you do is you make a small change in order to get it to work. You're making the smallest change possible. And then you run the tests and you watch them succeed. So the first step is to write a small test on code that doesn't work yet and do the most minimal thing you can possibly do to get it to get to green, to get it to succeed. You're not writing real code. All that you're doing is returning true or returning false or just doing anything so that you can get to green as quickly as possible. And you just do the stupidest thing that you can do that's quick. Then we refactor, and that's the important next step, right? We're at green. So at this point, we can start modifying the code that we just wrote so that it does something. And then we want to get back to, we keep going around all this around this cycle, right? Is that we may or may not, the thing that we just did in the refactoring, we may skip the add a small test part if we're still working on the refactoring. But we just cycle around and around and around, right? We add a little bit of code, we test. We add a little bit of code, we test. If it comes to red, we fix it, get it green again, and then add a little code and test. And at every stage there, we're not necessarily trying to get a finished product, as you don't want to be working on the code for more than about 5 minutes between tests. And even 5 minutes is kind of marginal. I get nervous when I work for 5 minutes without testing. So everyone understanding how this process is working. So your goal then is to keep things green as long as possible. If it goes red, you fix it immediately. Get back to green. As soon as you see that red, you get back to green. That's the next step, always. All right, so never leave anything failed and write code. So as I said, that's about a 5-minute cycle. So we're trying to get to green as quickly as possible, because that's our goal here. This is basically just the same thing that was happening in the other slide. It's that you want to make it run as quickly as you can. You never want to add a test or modify code if the code is red. So those are our 2 key rules. There are a bunch of other things that you might want to do in order to keep yourself sane. One of them is I always keep a to-do list, literally a physical one, a piece of paper that looks like this on the desk in front of me as I'm working. The issue there is that, remember, we're writing the code incrementally, a little bit at a time. We're only working on it for a minute or two between tests, which means that for most of this process, most of the code doesn't exist. And also, as you are working on the code, things always occur to you that you have to do within the next 10 minutes or so. So this is a to-do list that covers the next 10 minutes, or the next 15 minutes. It's just stuff that popped in my head while I was working, and I don't want to forget it. And I know as a fact that as soon as I start concentrating on the code, I will forget what I just thought of. So my strong advice is to write it down. Write it down on a piece of paper. It's easier, for me at least, on a piece of paper. If you don't like paper, well, put it into a little editor window or something, but write it down immediately somewhere so that you don't forget it. Right? The advantage for paper for me is that it's sitting there on the desk in front of me and I can't ignore it. If it's an editor window, it moves back behind my development environment and I forget that it's there. So this way it's visible all the time. If you have enough monitors that you can keep it open where you can look at it, well, fine, stick it on the monitor. So as I finish things, I cross them off. As I think about new things, I add them. In terms of minutes between runs, this is a graph out of Kent Beck's test-driven development book, which I recommend that everybody read it. This is an annoying, what's annoying is not the book. What's annoying is that the book is every bit as useful today as it was, 6 years ago, 7 years ago when Kent wrote it. The problem is that Addison Wesley, his publisher, in its infinite wisdom, has decided that there is not a computer book on the planet that is good for longer than a year or so. So they have not turned test-driven development, by example, into an e-book, which annoys me. I won't start swearing, but I was about to. Right? They should not have done that. Right? It's a book that all of us should read, but it's only available on paper. So buy the paper copy and read it. It's worth reading. Pass it around the office if you don't want to buy 100 copies of it. But it's not available as an e-book. But anyway, this is a graph out of Kent's book. Minutes between test runs. Now, first of all, notice the 0 column is that the vast majority of what he's working on is less than a minute between runs. Right? And if you add the 0, the 1, and the 5 together, that's most of his code. Rarely will he get above 10 minutes between running the tests. All right? So you've got to do this. It's discipline. It's that all of the agile processes are highly disciplined. Very low ceremony, right? Not a lot of paper, not a lot of written down structure, but they're highly disciplined in the sense of self-discipline. So you've got to discipline yourself to be doing this, is to be running the test constantly. Once you get used to it, you get nervous when you don't do it. But at first, you're not used to it, and it won't occur to you to run the test as often as you should be. You'll tend to want to write more code than you should be writing in between test runs. Now let's move on to this as a design process. Looking at this as a kind of design process. We've all, when working with an API, asked ourselves this question. Right? Is that you're trying to do something and it is 3 times harder or 30 times harder than it should be. Something that should be 1 function call is 15 function calls using lots of obscure variables and strange things that you have to look up, and it takes 10 minutes of Googling stuff to do something that ought to be a single function call, and it just drives you crazy. And the reason it drives you crazy is that the answer to this question is usually no. In other words, the people who design APIs rarely use those APIs as part of their design process. They design all the APIs first, and then they write some trivial piece of garbage using their APIs, but usually that trivial thing is optimized for the API, right? It's just the one test case that the guy had in his head when he was putting the APIs together. And then he looks at it and he says, well, it's not going to handle that test case because, or it'll handle that test case, but it's got to handle other ones too, but I don't know what they're going to do. So he throws in everything he can think of to make it general purpose. Now, rarely does that person actually write programs that do other things. Does everyone see what I'm saying? There's a bunch of great examples of this coming out of Microsoft, I hate to say it, but there are other great examples of this coming out of Apple too, so it's not as if they have a lock on doing things incorrectly. But there are a lot of frameworks out of Microsoft that I've worked with where you go through the examples that are part of the documentation and it seems trivial and easy to use and wonderful, and then you try and do some real work with it and all of a sudden you find out that it is way harder than you had ever imagined that it would be to do the same thing. That's the phenomenon I'm talking about. So we want to avoid that. We want to build our code around real examples. So the basic idea then is that the guy who's doing the code is guessing about what the interface looks like, and guesses are guesses. He's trying to guess what we're going to use the code for. And the guesses will be wrong most of the time. So the better approach, is to start off by writing the code that uses the API. Right? In other words, the way to think about this, if you think about the whole world, all the programs you're writing as being APIs that access small subsystems. If you were in my microservice talk yesterday, it could literally be that. Right? What we're doing then is API design. So what you want to do is say, okay, I've got a story. I have a scenario or some use case that I want to implement. And I'm going to implement that in terms of classes that use this API, that expose this API. If you write the story first, before the API exists, then you have the luxury of being able to add to the API exactly those methods that you need to add in order to get your story to work. Which means that for that story, at least, the API will be correct. It will also be complete, which is very important. In other words, there will be no methods on the API that are not required to implement the story that you're working on right now. Which is why you get 100% coverage. Because the API, the interfaces in other words, will only have in them those methods that you need to implement the story that's in front of you. All right, now, that process is an incremental process. And that's one of the other things that goes wrong with the API design process, the way it's done typically, is that they want it to be released in some kind of perfect form. Well, Agile doesn't believe in perfection. It believes in incremental improvement. So the basic idea then is that those APIs will gradually grow over time as stories are added to the system, and that's fine. So we're not trying at first to come up with an interface to our objects that will handle every possible scenario that we can imagine that that object is going to be used in. We start by writing an object that only does exactly what it needs to do the current story. And then the next story, if it uses the same object, well, we might have to modify the API a little bit in order to get that to work. Now, the reason we can do that safely is because we're using test-driven development. So the tests are in place from the first story, and we can run them when we make the changes that we need to make in order to get the second story to work. So we know that when we make a change, we haven't broken anything. And the API will evolve incrementally in that fashion. So this is a design technique. What I'm describing is design, it's not testing. We're just using the test framework as a way of being able to do design. It's a way of helping us do design. And we are dispensing with the drawings that usually comprise a design because we don't need them as we're working directly in the code. No point in drawing it and then coding it immediately and then throwing the drawing out, because what's that going to buy us? So people they look at Agile and they say, well, there's no documentation in Agile. And that's nonsense. There is documentation. It's the code that's the documentation. It's not some drawing of the code. It's the code itself. So the main issue then is that if you're doing it right, you are writing the client code before you write the subsystem that the client code uses. Most people do it the other way around, which is very much a cart before the horse problem. Right? In other words, most people try and design the subsystems first, put an API around the subsystem, and then write code to use that subsystem. And I would argue that that's backwards. Because when you're designing the subsystem, unless the code that uses it, the client code, exists, you don't know what the subsystem has to do. So you're just guessing. And what I want to do is eliminate all guesswork from this process. Guessing is waste. When you guess wrong too many times. So what we're doing then when we use this as a design process is that we're thinking in terms of interfaces. You invent the interface that you wish existed. And then you code to that interface. And only then do you implement the interface. Now the other interesting characteristic of this way of working is that if you're like me at least, you will always get the interface wrong. I have never once gotten an interface right the first time I came up with it. And if you look at the interface document itself, it looks perfectly reasonable. Right? Because whatever scenario I had running around in my head was imagining that it was going to be used in some way. Once I start actually trying to use the interface, I find flaws almost immediately. Right? Things that I need to do that it can't do. Arguments that need to be passed that aren't being passed. Arguments that are being passed that don't need to be passed, right? Which is in a way worse. So the point of this is to discover flaws in the interface. So the first few cycles around this, you're not actually changing the system in terms of going to green by adding code that works. What you're doing is going to green by changing the interface and then bringing your new version of the interface back to green. All right, so the first few revolutions in this process are all about getting the interface right. They're all about writing code that uses an API, and since we're writing code that uses the API, we find flaws in the API and we fix them before we write the code that's underneath the API. So at least the first 5 or 6 cycles around this, I'm tuning the API. I'm not implementing anything yet. I'm just making sure that my interfaces are what they should be. Now, as we're doing this, we're working from stories. And a story just in this form is adequate, right? And I should say this, I talked a lot about stories yesterday, but for those of you who weren't here, let me reiterate a little bit of this, excuse me. Is that a story is always a domain level thing. So what a story is it's a short narrative that takes a user of your system through some process to a result which has value for the user. Right? If there's no value provided to the user, you do not have a story. If the user can't say to you, yeah, this does a little bit more that's useful to me than it used to, then you do not have a story. So a story is not a way to disguise a requirement. If somebody put it another way, simply putting it in this form does not make it a story. If I say, as a user, I want a button so that I'll be happy, that's not a story. Right? Because there's no useful outcome for the user. The user could care less if there's a button there. They're trying to get some job done, and they want to make sure that the program does that job, that task, whatever that is. So you've got to be focused on the outcome. It's not just a user up here. It's got to be some actual role in the system, right? As a banking customer. And then some domain level task. I want to withdraw some money from an ATM. I can't spell this morning. And then I have a reason for that so that I don't have to wait in line. Now, some people have suggested, and I agree with this, that it actually makes sense to do this first. They say, I don't like waiting in line. Therefore, I want some sort of automated way to withdraw money. Right? Or therefore, a banking customer needs some automated way to withdraw money. And I think that keeps you focused on that outcome. I think that's a good thing. So the stories are the center of this design process also, because we're always going to start the design process from stories. So if you look at the story then, what we're trying to do is get some domain level statement translated into some kind of code that implements that statement. Right? So here we have a domain level statement that is translated into code. but we might have gotten it wrong. So the first step then, the first cycle, as I said, is that if we find out that we got the story wrong by talking to our users, we then need to modify the code in order to reflect that. Now this is an ongoing process. This happens all the time. This is what Agile is. It's taking an existing set of stories, finding out what's wrong with them, and fixing them. So that one-to-one connection, the fact that you look at a story and you look down here at the implementation and they match each other, that's essential. That's what makes it possible to be Agile in your system, that the code is directly connected to the domain. So that when a change happens in the domain, you know exactly where to look in the code in order to make the equivalent change at the code level. If you don't have that one-to-one mapping, you can't pull that off, and it makes everything much harder. Now, since the whole point of Agile is to get working code into the hands of our users as quickly as possible, if you double your development time because there is not a direct mapping between the stories and the code, you're not getting your code into the hands of your users as quickly as possible. So you fail. So having the design based on the domain is essential here if we're going to be really doing Agile. Which brings up the DBC process, right? The design by coding process, where you're designing an interface based on a story. You develop a test that stimulates the story. And then, as I said earlier, you fix the problems with the interface as you're working. And then you flush it out. Right? And by flush it out, I mean you use the TDD techniques that we were just looking at to then take the API that we now have correctly and take it to completion. So what I'm doing basically in terms of using this as a design technique around stories is that I'm taking the techniques of TDD and applying them at the architectural level in a recursive manner. This is sort of the TDD, an architectural TDD rather than an implementation level TDD. Is everyone understanding what I'm accomplishing here? So that's something that Kent doesn't talk about. It's something I do all the time, but I haven't seen it written down anywhere. And again, this is a 5-minute cycle as we go around trying to improve our APIs, trying to improve our interfaces. This is basically the same thing restated, right? You're implementing stories, one fragment at a time. You're running the tests, you're mocking things out, you're refactoring the interface as necessary, then you go back up. All right, now let's talk a little bit about behavior-driven design while we're at it, or behavior-driven development, rather, is what Dan at least was talking about. This has to do with the way that you would put the tests together, and this way of putting the tests together works or applies to both the TDD and also my design by coding approach. Is the basic thing that Dan realized is that things have to stay in the domain to be viable. So here's a customer lookup test, right? It's just doing some kind of test. The first thing that he came up with as he was doing this is that the test name should be a real sentence that tells you something useful. All right, now the point of that is that you can take code that looks like this and turn it into a result from a test runner that looks like this, and that's actually quite useful. So what he's trying to do is automate this process, and there are a bunch of BDD-related tools. This Cucumber is the one that's used most often, but there's a bunch of them that will do that. We'll look at your code and generate test results based on moving strings from the source code into the output by looking at the names of things. Better yet, the test name should tell you what the test is testing and what it means when the test fails. Right, is everyone with me here? If this was called condition test and it failed, I wouldn't know what was going on. But if I know that the test should fail when the condition is true, then I have some information to work with when I'm looking at the output from my testing framework. Right, the issue here, remember, is that these tests are very long-lived. Is that a test that you write today, you might be looking at the output from that test a year from now. So if all of your test framework, like JUnit or CUnit or whatever unit you're using, XUnit, NUnit, if all that your framework is telling you is this test failed, it sure is handy if the name of the test tells you why it failed. right? Because then you don't have to look in the source code to figure out why it failed. So naming is important. So what Dan started thinking about then is that what we want to be testing then is the behavior of classes. Right? It's all about behavior. We're trying to make sure that objects and classes behave the way we expect them to. So instead of, let me do that again, right? Instead of saying this is an order test that's testing some order, he says we're testing the behavior of shipping. Right? I'm not testing that a customer is valid. I don't even know what that means. What I'm testing is something got shipped to the customer as it should have been. Is everyone seeing the distinction there? It's an important one. So this is the difference between thinking about unit testing and thinking about the domain. It's thinking about the stories. Is that you're not thinking about the object. You don't test an object. What you do is test that the object is behaving the way it's supposed to. And that's, I think, the most important concept behind BDD. Even if you're not going to use any of the other frameworks, that's a critical concept. That you're testing the behavior of your objects, not the contents of them. So behavior-driven testing then is a kind of analysis. Is that, in other words, what you're doing when you're defining behavior is the equivalent of defining stories, or vice versa, though. Right? In other words, if you've defined a story, translating that into tests for behavior is relatively straightforward. So we have now not a testing process, but a design process. Dan has this format that he uses, which can be valid. If you're using Cucumber or something like that, you have to do it. But this is a good way to think about the test condition in order to get you thinking in terms of behavior. Right? Given that these conditions holds, when this happens, then I expect to see this behavior. And most of the test frameworks give you a means of doing this at the code level. So here's another example. Right? So in terms of doing it at the code level, here we have this notion of a given, right? Is that we're defining conditions that were the given part of that of the thing we were just looking at, right? So this is code that is implementing the givens, and then this is Cucumber here, or this is JBehave here, but they all work about the same way. But there's now a given statement that has a string associated with it. Those are givens, and then we have a test, and then inside the test will be the things that you're used to thinking, right? Search, for example. All right, I'm not going to dwell on this too long because a class on Cucumber is its own session, right? It takes an hour. It would take at least an hour or so to go through Cucumber. But I want you to give you a general feeling about how these testing frameworks look and how they work. Right? The important lesson, though, is that we are focused on behavior. So let's talk about some principles here. This is general principles. First of all, the tests need to be abstract. And by that I mean that the test cannot be written in such a way that it's making assumptions about specifics of implementation. Now, if we're talking about BDD, that moves us in this direction very easily. In other words, we're testing that the object behaves the way it's supposed to. When we ask it to do something, we verify that it did what we asked it to do. And we don't care about what state it's in particularly. The only time we would care about state is if it did something different when it was in one state than it did when it was in another. And the test for that then would have to check the behavior, change the state of the object, and then check for the new behavior. But we're looking for behavior when we're doing the testing. And again, the point of that, over and above the fact that that makes a good design technique, the point of that is that we need to be able to change the implementations of the objects without having to modify our tests. If we test for contents, if we test that some field has the value we expect, or some database has been updated the way we expect, then we're going to be in deep trouble if that field is gone because we had to modify the class definition because of some new story, or if the database has changed because we had to modify it in order to satisfy some new story. So we want to be isolated from those kinds of implementation level changes as much as possible. So again, by focusing on behavior, you can do that. The tests, of course, will always fail. I guess they didn't test the bridge well enough. But there are only a few possibilities if that happens. One is a bug, that's the easy one. In that case, you just fix it. One of them is that the behavior you're testing has moved somewhere else. Right? In other words, the object doesn't behave the way it used to because somebody else is now in charge of that behavior, in which case you have to move the test to somewhere else. Right? The test has to change also. And the third situation is that the behavior that you're testing isn't correct anymore, and that happens a lot. Right? Because it used to be that you had a particular behavior and then a new story came along and you had to behave a little bit differently. And in that case, you have to change the test or you at least delete it. Right? In other words, these tests are so small, changing the test is usually not worth the trouble. It's better to delete it and start over from scratch. Okay? In order to make this stuff work, there are a couple of principles that apply. Some of you have seen this slide more than once. But the basic idea is that the rule of thumb you should be using as you are writing your code is that it must be possible to completely replace the implementation. Throw away all the fields and replace them with different fields. Throw away all the methods, at least all the implementations of the methods, and implement them all completely differently. And the users of your class shouldn't know that you've made any changes. If you're using properties heavily, or you're using getter and setter methods heavily, you will not be able to do what I just said, because you'll be exposing too much information about the way that the object works. So as far as I'm concerned, properties are evil, as are getter and setter methods. You just should not be using them. Is that because the code is untestable when you're using them. It means that every time you do some minor tweak to the code, all your tests break. And I am not willing to spend my life changing tests every time I make a minor change to the code. So you have to write the code in such a way that it doesn't require these getters and setters, and I talked a lot about that in the sessions yesterday, unfortunately. So you can't go back and look at them, but it's part of the design process to learn how to do that. It's not hard to do, but it's different than the way most people work. But just to give you a feel for what's involved, notice that if I'm asserting on a value associated with dollars, that's not going to support different currencies. Right? Is everyone following what I'm saying? It's also not going to support different types. Right? In this case, it might be assuming that it's a float, and I might need to change it to a double at some point. Right? A friend of mine just came up with a bill that was like 3 trillion Uruguayan dollars or something. I don't remember what it was exactly, but it was some currency that inflation had just gone crazy. Maybe it was Vietnamese yuan, I don't remember. But there were 3 trillion of them, right? 3 trillion of them is not going to fit into a float. The fact that 3 trillion of them had the value of about $1 is an issue, right? Is that because you're going to spend trillions of trillions in order to do a large purpose, and that's really not going to fit into a float. It might not even fit into a double. Right? So working with the values is a problem. In other words, we're assuming something here that we really shouldn't be assuming. So if we avoid the get set methods entirely, we can do things in different ways. So I didn't put the solution here, but the solution, I should add another slide, would be to have the dollar be able to compare itself with other dollars. Everyone see what I'm saying here? If I declare a dollar and initialize it to 5, and then compare $2 against each other, to say to a dollar, are you less than this other dollar? That'll solve the problem, because the way in which the dollar value is represented is hidden inside the object then. All right, I'll type that up as code in a moment when I get the clips up. So we want to avoid these get set methods. Other rules. You don't want to do more than one thing at a time. People cannot multitask. They think they can, but they're wrong. Is that the context switching overhead does 2 interesting things. It reduces your IQ by 10%, and this has been documented, that if you're working on 3 tasks at once, your effective IQ is 20% lower than it would be if you were working on only one thing. And it also causes inefficiencies. It adds about a 10% inefficiency to your overall process. In other words, if you work on 3 things at once, as compared to finishing the first one, finishing the second one, and finishing the third one, if you're working on 3 things at once, it will take 30% more time to finish than if you're working on things one at a time. So we don't have the luxury to multitask. It's wasteful. And this applies with tests in spades, but it also really applies for practical reasons, is that you can't change the test and the thing that you're testing at the same time and be able to trust the results. You never want to change both the test and the object that you're testing simultaneously. So TDD would say, so change the test first. If you need to change both, change the test first, watch it fail, fix it, and then go around that loop. Okay? The law of Demeter, the notion of talking only to your friends, is an important issue here. The problem is this so-called train wreck. They call this a train wreck. Right? And you see code like this all the time. I should say, by the way, you see chains of objects like this all the time, where it's okay also. Is that what makes this hard is that getBody returns something that's completely different than a dog. And getTail returns something that's completely different than a body. So if something goes wrong, we don't know where it went wrong, and we don't know what class is involved. What we really want to do is a one-level call, right? We don't want to define in the code, in other words, how a dog expresses happiness. So that makes the behavior, again, we're defining an interface here, which is behavior, specified in terms of behavior. But by doing that, we can identify exactly where the problem is. Either it can express happiness or not. Okay? When you're doing tests, you always want to clean up after yourself. In other words, it is often the case that you have to put the environment into some kind of state in order to be able to run a test. Well, it's important that you put it back where you found it. Put everything back where you found it. If you have to create a file, your test has to check that the file exists, move it someplace, if it does exist, create the file that your test needs, run the test, delete the file that you just created, and then move the original one back where it was. Right? You always want to leave the system in the same state that it was in when you found it. Which is a good reason to be using mocks, because that's really annoying to have to do that, right? It's much better to simulate a system that's in the state that you want than it is to have to change all this stuff as part of your test scripts. But you need to do this in the actual test code, if nowhere else. Is that I used to do it in shell scripts before I ran the test, and that got to be too awkward. It's that I want everything in one place. So it's easier to move things around in code than it is to move them around in scripts before you run the test. All right, so before I change the screen then to, or go into an example, are there any questions about any of this general stuff that I'm talking about? Mm-hmm.
Yeah, in a pattern like MVVM, that's quite reliant between the view and view model properties.
Well, when you're working with MVVM, there are several points where you can plug tests in. One of them is that you can plug a test in between the view model let's say between the client and server. That's a better way to look at it. In other words, with MVVM, typically you've got a little bit of client-side code and you've got a little bit of server-side code, and they're hooked together with some kind of glue. Well, that glue layer is a good place to insert a test. So you could then test the client side without the server having to exist, and you could test the server side without the client having to exist by simulating the behavior that's going back and forth across that connection. Is everyone understanding what I'm suggesting here? Right now, that handles the server side completely, because the server is, after all, a server. In order to fully test the view side, you've got to be using some kind of tool like Selenium in order to simulate clicks and so forth, in order to test that the view is working the way it should be. So that's a little bit harder to test in an automated way, because you've got to use tools that are inherently harder to use. Selenium is not the easiest tool in the world to use. But generally speaking, what I do is I tend to test the UI stuff last, because the other stuff is automatable, so that the development goes much faster. And once I'm convinced that the server side is solid, then I can just focus on the UI side and do the tests for the UI side by themselves. The other thing I should say is that it might not be worth the trouble to automate everything. Right? It's an ideal for all of your tests to be completely automated, but in practice it might take more time to do that than it is to have a user run the test 100 times. Right? In other words, run it manually. I don't like manual testing as a general rule of thumb, is that you want to be able to test as a side effect of a check-in, for example. You ought to run all of your tests every time you check in. Or at least run all of the tests that are relevant every time you check in. It might take 6 hours to run the full test. But you can't do that unless everything's automated. And if you have any manual testing going on, there's going to be this huge pressure to just not do it because it's too time consuming. So generally speaking, I think you should automate as much as you possibly can, which includes the UI. So I do use Selenium more than I want to. Is that it's not a tool that I like very much, but it does do what it needs to do. Mm-hmm.
So you say to write the test first.
Mm-hmm.
You've got your dog express happiness example.
Mm-hmm.
How do you deal with the six? But you say not to edit the object and the test at the same time. But
Right.
if you don't add something into the object, the express happiness method, it just won't build, and you can't see it.
Well, it will. I'll demonstrate that in a moment. But the short answer is you build the most minimal thing you possibly can build to make the test appear to work. Right? So you might implement express happiness as return true. I'm happy. Right? And it's not really doing anything, but it allows the test to pass at least. And then you go in and modify the express happiness method to actually do something. And you do that incrementally, applying the same technique recursively. I'll demonstrate that in a second.
What mocking framework would you recommend for Java?
In Java, I use PowerMock and Mockito. The Mockito is Mockito. And Mockito does most of what you want, but it won't mock static methods, which I need to mock on occasion. So PowerMock is a layer around Mockito that adds the ability to mock static and final methods, which is kind of nice. In the Microsoft world, I've used mock with a Q mostly, though there are other frameworks that will also, mock wouldn't modify, won't let you do statics either, which is kind of annoying. But there are other mocking frameworks that will allow you to do statics in the Microsoft world. I haven't used them though.
How do you ensure that mocks stay in sync with the thing that they're mocking in terms of interfaces?
That's discipline. That comes back to discipline. When you change one, you've got to change the other. But you know, the mock is always a kind of temporary thing, right? Our goal here is to write real code, not to write mocks. So ultimately then, right, it's our goal to get rid of the mocks and replace them with something real.
Or spies?
Well, eventually they might turn into spies. They might all turn into spies. But there's no point in keeping the mocks in place if you have a real thing to test against, because it's a better test. So mocks have a relatively short lifetime. And that's the whole point of a mocking framework, is that you build the thing, you use it as long as you need to, and then you throw it out, right? It's not real code. The downside of that is that the mocking framework sometimes can be very wordy, and it can actually take less time to just write the code than it would be to do the same thing using the mocking framework. Right? So often I will use the mocking framework for a while, and then I toss it relatively quickly and replace it with something that I've written. Okay? All right, so let's look at an example. Let's take the problem of logging in. I want to authenticate a customer. Now, I mentioned this the other day when I was talking about story development, but every time we do something in an agile way, we need something to model. We need what's called a system metaphor. So I've come up with a metaphor here for login. Right? The metaphor is a guard standing at a door. The guard asks the customer to sign in. The guard finds the customer's signature card in the card file. If the signatures match, the guard allows the customer into the room. Right? That's my basic story here for logging in. Now, the advantage of working with the system metaphor is that it gives us, first of all, an easy way to talk about the code. Nothing's abstract here, it's concrete. And secondly, it gives us a set of useful abstractions. Right now, before I talk about the abstractions, though, let's talk about the notion of roles and responsibilities. What I care about as I put these abstractions together is the role, not the actor. In other words, the actor is the person who's typing. I'm never going to model the person who's typing. What I am going to model is the role that the person is in. So everyone understanding the distinction I'm trying to make here. So if you have, the example I used in class the other day was that if you have a timesheet authorization system, it's the role of a manager to authorize timesheets, it's the role of an employee to fill them out. There's no overlap between these responsibilities. The fact that the same person can log into the system sometimes in the role of employee and at other times in the role of manager is irrelevant to me from a programming point of view. As far as I'm concerned, they're completely distinct roles. It's the roles that matter. So what we're identifying when we look at our story then are the roles. And there are several roles here that are important. Guard, signature card, card file, signatures. Right, these are all key roles in the system. Okay, so everyone with me here? And the guard asks the customer to sign in, looks for things in the card file. So let's go look at some code. I'm living dangerously here by trying to talk and code at the same time, so I will ask for your indulgence if I make a mistake, or when I make a mistake, let's not say if. All right, this is Eclipse. I'm going to do this in Java. I've built a small test framework to test around. Is that the project in question is this little demo project. And I just have two simple files. One of them is the thing that I am attempting to test, right? In other words, this is the object that I'm ultimately going to build. And then there is the test itself over here. Now, I should say that when I do this, usually, I don't want to be swapping back and forth between two files. It's just an annoyance to do that. So I will initially build the classes that I'm trying to build in my test source code, right here in the TDD test.java file. And then once I get the test to work, then I'll move it off into its own file, which is where it should be. But doing that at first, I don't want two windows up. It just slows me down to have two windows up. So I do everything in one window usually. All right, now what I've done in this little test file is I've provided kind of a framework for testing. This is just a pre-built file that I use all the time. Most of the stuff in here is in here because I forget stuff. This is a side effect of having children. And so I put, this is more for me to remember how Mockito works because I'll forget the details between now and 2 weeks from now, which is the next time I'm working on this code. So that's convenient in a class like this because I can show you how Mockito works or how a mocking framework in general works. They all work pretty much the same way. The test class, typically there's some code that you have to run ahead of time in order to prepare the system. Typically in both C# and in Java, that's done with some kind of annotation, or the C# equivalent, you've got brackets around this instead of an @ sign, but it's basically the same thing. So what this stuff is doing is just getting the test framework so that it'll work. There's a test class of some sort. Now, the Mockito framework is what I'm using to actually do the testing. Mockito is basically made up of a big pile of static methods. So by extending the Mockito class, I don't have to say Mockito dot everywhere. So this is just a convenience. And it may not be possible, but since this class is used for nothing but holding tests, and it doesn't have to extend anything else, I might as well leverage that extends relationship so I don't have to be typing Mockito.x and Mockito.y all the time, because x and y will just be inherited this way. And I can just say x and y and get it over with. So is everyone understanding what I'm saying? Now I'm in NUnit, right, or in JUnit, or actually I'm in both of them. Is that there are two setup functions you can call and two teardown functions you call. In the case of Java, before class is run before any of the tests are run, and after class is run after all of the tests are run. So this is typically used to set up the external environment and to put the external environment back the way it was. Before and after are tagging functions that are run just before each test and just after each test. And notice what I'm doing is creating an object to test, an object, it should be OAT, what am I thinking? It should be OUT, object under test. But I guess I'm Scots, so it must be OUT. But the issue here is that I'm producing a new object to test for each test, so that every test is running on a clean object. That way I don't have to worry about the object entering some funny state and that would mess the test up. Then I have a bunch of test functions, and these work about the way you would expect, is that every test function is labeled with test, and then there's some kind of test that has to work. In this particular case, it's testing that an exception that we expect to be thrown is actually thrown. Here's a test where I'm setting up a spy. So what I'm saying is I want to spy on the system.class object. So then I can access things through the spy, and it's as if I'm accessing things directly. Again, I'm going through this stuff pretty fast, but I just wanted to give you a feel of how this sort of thing works. Here's a simple interface that I'm putting together, and here I'm actually producing an implementation of it. So the question that came up earlier about how do you code to something that doesn't exist, this @mock annotation is actually going to produce an implementation of the sample interface that doesn't do anything. Right? If it returns a no numeric value, it's going to return 0. If it returns a Boolean value, it's going to return false. If it returns an object, it returns null. It doesn't do anything. But it's a legitimate object. It actually implements the interface in the background. And then it declares, and then it actually instantiates the interface and assigns it to S2. So from this point forward, S2 actually points at an object of type sample interface. Is everyone following what I'm doing here? And then I can use that object. So I could use it directly, right? As S2 is a mock. Here I'm doing exactly the same thing, but I'm just doing it as code, right? You could do it either way. So I'm saying produce a mock of the object that implements this sample interface. And then I can start asserting on it. I can call methods that are in that interface. I can call the methods and I can send values. I can check for certain conditions. So I'm saying, when I call this method, then do this. So later on, when I call the method, that's going to actually throw the exception. Does everyone see what I'm saying? In other words, this statement here, this when statement, is changing the behavior of the mock so that when the getX function is called with a -1 argument, it will throw that exception. So down here in the test, where I actually call getX with a -1 argument, it will throw an exception. So this is effectively adding code to my mock. Okay? Then I can also verify, here's one for return, right? When I call getX with the argument 1, then the mock will return 1. So as you can see, it might be easier to just implement the interface with a little function that returned 1, right? This is kind of hard to read, and there's some work here, some stuff to read. There's some work here, but I don't really have a strong feeling one way or the other as to which approach you want to take. It could go either way. And then you can verify that things work the way you want to. So you can, for example, here I am saying I want you to verify that that foo was never called. Here I want to verify that getX was called with the argument 1 exactly once. So it's keeping a record. The mock is keeping a record of how many times it was called and what arguments were used to call it. And then we can effectively play that back. We can also stub stuff out. I don't have some examples here, but you can. I could say any of this code could go up in any of those test methods. So I could say, for example, throw, and then instead of the ellipsis here, there'd be some exception object. When this mock is past the F message, right? Return this value true when this mock is past the some method argument or some method message with this argument. And then in this case, the argument is anything. So is everyone seeing how this is working? That's my basic mocking framework. I'm not going to go into this in a lot more detail. So let's go back up here and start thinking about our guard situation. Oops. All right, I want to be able to write some tests that I can use for developing code. Now, just to bring it back for a second. Oops. Oh, why didn't Keynote come up? It's being unhelpful here. Let me just bring it up anyway. So I'm going to go back up to my card. Right? The guard asks the customer to sign in. The guard finds the customer's signature card in a card file. And if the signatures match, allows the customer into the room. All right? Is everyone with me? So, let's go back over to the code. I know I'm going to need a guard object. But in fact, it's probably a bunch of them. I don't know what's in there yet. A signature card. No, I'm going to need one of those. I probably need a card file. Again, I don't know what's in these interfaces yet. The whole point is to figure out what has to go into those interfaces. I need some kind of test. Oops. No, I need to spell interface correctly. I need some kind of test. Now, what would the test should be? So maybe the guard should. Let's do the easiest case first, which is not allow customer into room when signatures don't match. When I said I want the name to be descriptive, I meant it. All right. So let's put it in here. So the guard, and I need a return value. In this case, it's nothing, right? Because it's just a test function that's returning here. This is not the real code. It's just a test function. Is everyone following me so far? Now, I'll run it. And it didn't do anything. Why not? There's no assertions, right? So. Okay, is everyone following me here? So now I can run this. Hopefully I can run this. It's coming up red. So that's a problem. Why is it coming up red? Oh, thank you. See, this is the problem with living dangerously. Is you do stupid things. Let's just run it again. It's still failing. What am I doing? That should succeed. I don't know why it's not succeeding at all. So, sometimes this is Eclipse that's screwing. This is Eclipse that's screwing up, I think. Well, I'm just going to keep going as if it's going to work, and we'll move on. I don't want to screw around up here. But the point is that now I have some interfaces, and I have a test, but I don't have anything else. And ideally, I would then get that to green. Now, remember, there was a procedure that we had to go through that the story was defining. Right, is everyone following me here? In other words, the customer was going to present the ID. The guard was going to compare that ID, was going to sign in, is the way the metaphor went. Right? So at some point, we have to have a sign-up sheet. Right? And I have to have a customer. And I have to say to the customer, sign in. And here's to that sign-up sheet. Is everyone following me so far? So now I'm actually writing code. I'm writing the story out. And then now I have the sign-up sheet, so I have to say to the sign-up sheet, let's see, does the signature match the signature for my customer? Right? Is everyone seeing how this is how I'm thinking here? I'm just going through the story. I'm just implementing the story directly. I'm building a UI. Or not a UI, I'm building an API. Now, none of these methods existed. In fact, half of these classes don't. So I need a sign-in sheet. I need a customer. customer has to have a sign-in method. Which is past the sign-in sheet as an argument. The sign-in sheet has this long thing, which I'll just copy because I don't want to type it again. And it's past the customer here. I need to return value, Boolean. Semicolon. All right, now I don't have customer objects yet, right? So I need to mock them. This is a customer. And I need a sign-up sheet mock. All right, is everyone with me so far? And I can then assign those down here. And now it compiles. Is everyone following what I'm doing? Now, I look at this and I go, well, what happens after the signatures match or don't match? In other words, what am I going to return if the signature matches? Is how do I indicate that the customer has signed in successfully? And actually, my story is at fault here. So let's go back to the stories for a second. Oh, still here. The problem is that I didn't have this code, and I needed it. In other words, I needed some indication that the customer has signed in successfully or not in order to know what to return here. Is everyone following what I've done wrong? So I need to modify. Oops, let's just stay here for a moment. So there's an abstraction here, badge, which I need that doesn't exist. So I'll go back to my code, and I'll introduce a badge. And then I'll go down to this method. Does the signature match for? Yeah, it does, but maybe that's not the best name for this method. Let's say get badge if signature matches the signature for. And then it's going to return a badge. So I'm happy with that. See, I'm changing the APIs as I'm working in order to reflect flaws that I find in the APIs as I'm putting my story together. And then I can go down here then, and I'm going to have to modify the interface. Or I've done that rather, but I have to modify this call because it's not correct anymore. And now it compiles again. All right, so I'm going through this design loop, repetitively changing things as I discover flaws in my APIs. I'm actually designing, in other words. I'm not designing on paper, but back when I did design on paper, this is basically what I did. Just that instead of writing code, I was making a drawing. But I think this is just as easy to read for me as a programmer as that drawing ever was. So, you know, I don't use UML much anymore. It's kind of an odd thing is that if you search for UML reference, the UML reference card on my website is actually the first link that Google returns on the first page. So I'm the world's living expert on UML, and I haven't used UML in about 5 years now. So this tells us something about the validity of Google, but there it is. I guess that doesn't stop me from being an expert on it. I do know it pretty well, but I haven't used it very much. I use activity diagrams, but that's about it. On the other hand, you can see how this process is working. Right now, I have to have an assert. I want to assert that B is null here, right? Because I expect this to fail. So now I have a test. So I'll get to the question in a second. Let me just finish the thought, right? So now I have a test. So now it's probably not going to work, but if I were to run this test now, I would expect to see it, well, it's still failing for some odd reason, but I'd expect it to go green at this point, right? Because the default behavior of the mock is to return null if it normally returns an object.
Did you put empty arguments at the method?
The arguments where?
At the end of the test method?
What arguments? Returns void, there's nothing to it.
Yeah, but
The code is compiling cleanly.
input the argument.
I don't know what argument you say, you think I'm missing.
Test method, God should not allow
Yeah,
the other hand.
there aren't any arguments.
Yeah, I did it.
Nope, there aren't any arguments. Right, the test methods, remember test methods are called by the testing framework, not by me. So typically there won't be any arguments in test methods. But is everyone understanding this process? Because that's the main thing I want to get across here. So what I'll do from this point is just keep doing this. Right? I have a test that works, it's now green. So the next step probably is for me to go back and start flushing out this method so that it's not just stupid. Right? So everyone see what I'm saying? The next step is I would actually implement that interface with something very lightweight. And then that would go to green. And then I would just keep working on it until I got something I was happy with. And then I could gradually, again, replace these mocks with real things, one step at a time. As I was doing that, I would find more flaws in the story level code. Again, what this test method is doing is just working through the story, basically. And then I would use those to change the interface, to get the interface right. So by the time I was done, I would have interfaces that were optimized to work. In other words, they would do exactly what I needed in order to get the story to work and nothing else. So I'm pretty sure they're going to work in the real code. I'd have the story flushed out, which is pretty nice. Right? If this was actually API design, I'll have it, the test will comprise a set of examples of how to use the API, and that's a nice thing. I will have 100% test coverage because I will have only implemented the methods that I needed to get this story done, and I will have only implemented in those methods the code I needed to get the test to pass. So I have 100% test coverage at this point. I have a minimal implementation. There's no extra stuff. And I actually have an architecture, but my architecture, you're not really seeing it here because I haven't drawn a picture, but the architecture is my domain level definition of the problem, my little story. Is everyone understanding what I'm getting at? And if we go back to the last of the slides here, the issue is that there is a direct connection then between the code and the story, which is what keeps my code maintainable. Right? Something I'm louder. I guess I wasn't talking to the microphone when I was sitting down. Hopefully you all heard me. But it keeps the code maintainable. It means that when I change something here, I know exactly where to look down. So if you want to learn some more about TDD at least, Ken Beck's book, as I said, is invaluable, because I recommend it strongly. Ken Pugh talks a lot about acceptance testing, which is essentially what I'm doing here, so I think his book is pretty good also. And then there's I didn't list it up here on this slide, but there's also my video, the one that's in the holo.com/slides directory, which basically takes the example that I was just going through, but it does it in a little bit more detail and a little more coherently, since I wasn't trying to live dangerously and actually type and talk at the same time. But those are all resources that you can use to follow through with this. So, are there any other questions?
You extracted the interface names from the story. How would you name the implementation classes using those interfaces?
Often the interfaces wouldn't remain interfaces, they would actually turn into the implementation classes. In other words, I'm a big believer in making the code as simple as possible. Now in theory, if you're doing like a pure object-oriented design thing, everything should have a formal interface, and the code should, you have implementation classes that implement the formal interfaces. In practice, that's really annoying. right? You've all done this, right, where you're tracing through code, and suddenly the debugger is sitting at the interface definition instead of the actual code, and there's no way to go from the interface definition to the actual code. There's no link there. That really annoys me. I hate that. So the only way to not do that is to not have the interfaces. Now, if an interface is only going to be implemented by one class, what's the point of having it? And the answer is usually there isn't one. So these things start out as interfaces, but they turn into classes pretty quickly. The only reason I did them as interfaces is because the mocking framework is working from interfaces. So the mocking framework is going to implement the interface for me, and at first that's really handy. As this code evolves, the mocking framework is going to be less and less interesting. In other words, as I start actually implementing the classes, then the interfaces will gradually go away, and the mocks will actually gradually go away because I can say new and actually create an object. And I'll have the class when I'm finished. So if the interface had to stay there for some reason, I would come up with a reasonable class name. Right? So signature card might be an interface, for example, if there were several variants on the signature card. But usually that's not the case, is that usually I don't need as much abstraction as I think I need when I start out.
How would this approach work in a team? For instance, if you have two similar stories, kind of working with the same objects, and none of the objects exist, wouldn't the two people, or four people if they create kind of the same objects in parallel?
Well, in practice, it's not really a problem. In theory, you're talking to each other. At least I hope you're talking to each other while you're working. If you're all working on the same thing at the same time, you should all literally be working on the same thing at the same time. In other words, you've all heard of pair programming, I assume. I'm a big fan of pair programming. I think pair programming is a spectacularly effective way to work. But there's also mob programming, right? The difference between a pair and a mob is how many people are involved, right? A mob could be 4 people or 6 people all working on the same code. And I see nothing wrong with that. So if one of the things about Agile that people really have a hard time with, and you just have to get over it, is that Agile is all about face-to-face communication. At the center of the Agile Manifesto, or the center of the principles, it says that the most effective way for people to communicate is face-to-face. And everybody wants to work distributed, but that's really, really hard. And if you're all in the same room, getting together for 20 minutes or 30 minutes while you work out a piece of shared code so you can all go off and then use that on your own little projects is much easier than if you're spread out across 4 continents. And even if you are working remotely, you still have to get together. So even if you can't get together face-to-face, you've got to get together on Hangouts or something. Which means that somebody's going to have to give with respect to time zones. Somebody's going to be working at night, or somebody's going to be getting up really early. So if you're programmers, probably you should go in the working at night direction, because nobody I know can get up early and function, but including myself, which makes even a 9:30 session kind of problematic for me. But the point here is that when you distribute things geographically, Agile slows down a lot. You get about a ×2 to ×4 performance hit when you try and work remotely. So people say, well, I want to work remotely, but if you're working remotely in order to do some cost, in order to get some cost savings, and you've got a ×4 performance hit because you're working remotely, you have to run those numbers and see if you are actually paying 4 times less by having a remote team than you would be if everybody was together in one room. And it's just a accounting equation, but somebody's got to run that equation, right? So I wish I had a better answer, but I don't. But the basic idea then is if you're all working together on the same thing, you've all got to be working together on the same thing. There's no easy workaround for that. All right. I have 2 minutes according to my clicker. Well, as I said, I'll be around. I have business cards up here. Feel free to take one if you want to get hold of me by email. Sign up for the mailing list. And more importantly, have a good conference, and thank you very much for coming.